A potentiometer is just basically made of a wire of uniform cross-section area. So this is the resistance wire which is connected to a meter rule. So in that case, whatever that we have here is a jockey, so meaning this jockey can be moved along the wire, and now it brings connection. So you can be able to move the jockey close to B, you can move the jockey close to A. So meaning that if you bring the jockey close to A, the galvanometer is going to deflect in one direction. If you move it close to B, it's going to deflect in the opposite direction. So meaning that there is a point where the jockey can lie and this will show zero deflection. That point where it shows zero deflection, that is what we call the balance point. And once you have gotten the balance point, you can be able now to use the galvanometer. Of course, we have E naught is the known EMF, but EX is the EMF that we are trying to find. So with now that balance point obtained, of course we know from point A to point B we have resistance, a resistance wire. So we are going to say now, once you have gotten the balance point, you are going to say E naught over EX should be equals to AB. Why? The length of AB is where the potential difference is 3.0 volts. So we're going to say, comparing E naught and EX, we're going to use the length here. So this is going to be E naught over EX is equals to the length AB divided by the length from A to where you got the balance point. Now, from instance, from here we have 0 and it's spreading over the 100 centimeters. So if you get the balance point at point C, let's say that is the 35 centimeter mark, it will mean that the PD across EX is equal to the PD AC. That's why we have the balance point. So we're going to say E naught over EX is equal to the length where you got the balance point, and that is going to be what? That is going to be our length AC. Now, since we know this EMF at this point, we are going to substitute there and say 3 over EX, which we don't know, we're trying to find. This is the unknown. PD should be equal to AB, which is 100 divided by 35. So our EX is going to translate to 3 times 35 divided by 100. And in that way, we can be able to get the PD using the potentiometer. So this will be 3 times 35 over 100, and that translates to 1.05. This becomes 1.05 volts for this particular question. So anytime you're given a potentiometer, you are going to try to adjust the jockey so that you get a point where the galvanometer shows zero deflection. The galvanometer shows zero deflection because there is no current flowing. If current is not flowing, it means that the potential difference across AC and the potential difference across here, they are equal, they are balanced. Then from there, we can be able to compare. E naught is the PD or the EMF across point A, B. Then along the wire AB, then EX will be the PD across AC. So using the comparison of the lengths, we can be able to find the unknown EMF. Another concept that you need also to understand how it works out for physics is the concept of a potential divider. Our V in, this is the voltage, which is the input voltage. And then here we have our R1 and we have resistor 2. So what is going to happen is that whenever you're having these resistors in series, of course the total resistance in this circuit is going to be R1 plus R2. Then we can now say total resistance is equals to R1 plus R2. And using Ohm's law, we can be able to say that current in the circuit, using Ohm's law, current in the circuit is going to be V in divided by total resistance, which is R1 plus R2. Right? So this is the current around the circuit. So something that we need to remember, for a series circuit, current is the same throughout. Current in this resistor is the same, and current in this second resistor is the same. So if we are trying to tap a voltage from this end here, if we try to tap a voltage from this end here across resistor 2, it means current that is passing through resistor 2 is the same current that is passing through resistor 1. Then if we want to know the PD, and this PD across this resistor, we are going to call it V out. So which means that V equals to IR, right? Resistance of this resistor times the current that is flowing through the circuit is going to be our voltage using Ohm's law. Then our V is what we call now V out is equals to I. Our I is here, the one that we have gotten. Our I is this one, which is V in over R1 plus R2. So that is V in over R1 plus R2. Then times the resistance where you are tapping, where you are getting the voltage out. Now that becomes what? Times R2. So that's why this formula, if you just write this R on top of this one, this formula becomes R2 over R1 plus R2 times is going to be 4 over R1 plus R2 is equivalent to what? 2 plus 4, that's going to be 6 times V in, which is given as 12 volts. So we are going to have 12 volts here, and that is going to be equivalent once here, it goes twice, and then that becomes 8 volts. So you can see the voltage that is removed from this resistor is 8 volts. Now the purpose of a potential divider is to split voltage, to reduce voltage, so that you can be able to use maybe in different components. So that if you are having a radio, for instance, and that radio does not use 12 volts, you need a potential divider that reduces the voltage so that you can be able to use for a particular purpose you want. So some of the questions that you are going to get are questions whereby you have variable resistance. You have a resistor here, for instance, you can have V in, because remember this V in here, we can be able to write R2 on top of R1 plus R2, and then now our formula becomes this. When you are working out V out, this is the formula you usually use during your exams. Now suppose we are given a question like this one, whereby we are told that resistor R1 is 2 ohms, resistor R2 is 4 ohms. Then we are supposed to work out the value of V out. We are going to use this formula. And something that I've opined here in this channel is that R2 is the resistor where the voltage is going to be tapped from. So if this is R2 and you are removing V out from this resistor, then you are going to use this R2. So it's not automatic that it's always R2. It's only that you check where the voltage is removed from, which resistor is the voltage tapped from. So if the voltage is tapped from this point, our R the resistance you use at the top here will be this resistor here. Okay, so in this case we are going to say that our R2 is 4 ohms. So we shall say the thermistor is a device, is the type of resistor whose resistance depends on the temperature. So if the temperature of the surrounding increases, how is it going to affect the V out? So we know that if temperature decreases, so if resistance decreases, then the V out will be smaller. So the voltage out, the PD that is getting out will be smaller, because if the resistance decreases, if this value decreases, then it means that V out is going to be smaller. So if temperature decreases, so PD, which is the V out, decreases. During the dark, of course, this is a light dependent resistor, LDR. So meaning that during the dark there will be high resistance, and when there is high resistance in this connection, there will be a larger potential drop that will be across the lamp. So meaning that the lamp is going to light brighter. So during the dark there will be high resistance, so there will be a larger potential difference across the lamp, and it's going to light. But during the day there will be a lot of light, and that the presence of the light is going to decrease the resistance, so there will be a less PD across this, and this lamp is going to turn off during the day. But at night, what will happen? There will be very high resistance because it's dark. There will be very high resistance here, so there will be a larger PD across the lamp, and then it's going to turn on like that automatically without any person coming to be in control of it. And if you have gotten value from Proflan YouTube channel, consider subscribing so that anytime I'm going to do more tutorials on physics, you'll be notified. See you in the next video.